of a rigid body by using basic trigonometry. So what I'll do is I'll go through a review of basic trigonometric identities you got to know, and then I'll just illustrate what I mean by computing absolute motion using trigonometry by solving a bunch of problems. So trigonometry review. This is section 16.4. So this is a circle with radius r, okay, and theta is the angle between two line segments from the center to the circumference, and let's say that this is r. So oftentimes we want to know what x is if we're given r and theta. So what we can do is drop a perpendicular from the center all the way down to the line segment I've shown there. Turns out that this is 90 degrees, and so x by 2, which is this half of the length of the line segment, is simply r times sine of theta divided by 2. So the reason it's theta divided by 2 is because this angle is theta. What we're interested in is half that angle. So then we can use the sine relation, right? So x is 2r sine theta by 2. The second thing which will come again and again is to be able to use the Pythagoras theorem. A Pythagoras theorem is only valid for a right triangle. That is, one angle has to be 90 degrees. So for example, if this length is 5, the other length is 12, then the question is what's the hypotenuse, which is the side opposite to we do it this way. We call this x. Let's call this a, let's just call this b. So x square is a square plus b square, and so x is square root of a square plus b square. Okay, and the third and final thing is, in general, you'll see that we will have triangles in the figures which I draw in the problems. And when you're given two sides and one angle of the triangle, or three sides of the triangle, you can completely determine the sides or the other sides and other angles. So let's draw a random triangle. Okay, and let's say that these sides are known. Okay, so two sides and angle is given. So as long as there are three pieces of information about a triangle, you can find any other angles and any other sides, which is the third side of the other two angles. So in this case, if I want to find this angle and this side, x, what do? How can I find x in alpha? Law of sine. So law of sines states that, well, let's call this beta. Well, I don't quite need that because that's going to be 90 minus the rest. So x divided by sine of 30 degrees, and the reason I did that is because the 30 degree angle is opposite to the side of length x, equals 2 divided by sine of alpha. If you like, let's call this beta, and this will be 3 divided by sine of the angle opposite to the side with length 3. This is the law of sines. Now, this by itself will not help you to solve for well, in principle it can, because you know that beta is 90. So what's angle beta? Beta plus alpha plus 30 degrees is 180, right? Because the sum of the angles of a triangle should be 180 degrees. So from that, you could figure out what beta is. It's simply 150 degrees minus alpha. So you could, in principle, find beta, well, you could find alpha by putting this beta in here. You'll get 3 divided by sine 150 minus alpha equals 2 divided by sine alpha. So using those two, that equation is solve alpha. That's one way to do it. The other way you can do this is you can use the law of cosines. Law of cosine, which states that x square is 2 square plus 3 square. These are the adjacent sides, the other two sides, minus 2 times 2 times 3. These are the two sides again, which I have over here, times cosine of the angle between the sides with length 2 and 3. So sine of 30 degrees. So cosine of 30 degrees. So this can help you to find what x is. 2 square plus 3 square minus 12 cosine. Okay, so that gave me x without having to find alpha and beta. Right? I did not use alpha and beta here. With the first expression, however, if you want to find x, then you have to find alpha or beta, right? Because x divided by sine theta is a function of alpha and beta. So you can choose what you want to do. This is simpler if you do not want to find alpha beta. If you want to find that, then you do that. Okay. But you should remember these two rules. So you could apply this again for sine. This is for x. You could do it for 3. It would be 3 square equals 2 square plus x squared minus 2x times 3. X times 2 times cosine of the angle opposite to 3 will be beta. You can apply this cyclically for sine x or 2 or 3. This depends on what you want to find. Okay, so these three things are kind of important because we'll see that they'll come up again and again when we solve problems related to absolute motion in this particular section. Any questions? So if you, I did post this slides on Blackboard on Saturday. It should be there. You can, if you want, you can take a printout. I've also posted the next two up for this week. Okay, so this is a famous mechanism. It's a crank-sided mechanism, and it'll come again and again in the course. So let's try to solve this problem. The crank AB, okay, is rotating with a constant angular velocity of 4 radians per second. So determine the angular velocity of the connecting rod CD. So we got to find at the instant when theta is 30. So we're given theta is 30 degrees. We're also given that I'll call it omega AB, or well, let me do it this way. We call this angle alpha. So alpha dot is 4. Okay, and I'm going to put a negative sign just so that I know that's negative. Clockwise rotations, okay, things going clockwise are negative. and things going counterclockwise are positive. And then I'm also asked to find the angular velocity of the connecting rod CD, okay, or this is the connecting rod. The angular velocity is simply theta dot. That's the unknown. Okay, so what my goal is to find a relation between theta and things which I know, which is the sides 600 and 300 and perhaps 4. And then once I find theta, an expression for theta which does not have any unknowns, well, or theta as a function of alpha, so alpha dot is known, then I can take the derivative of that expression to find what theta dot is. So I'm trying to get theta as a function of alpha, so that I can find theta dot, which is d dt of f of alpha. Okay, so I'm trying to get that expression first, so that I can differentiate and get theta dot. So I need to find theta as in terms of what is given there, which is the sides and alpha. So to you, can you think of some way in which I can relate theta with alpha? What would I do? So sine, when you see triangles which are not right angles, you would think of law of sines, law of cosines. If you use law of, yeah, question? Yes. Oh, my sorry, bad. This is just a notation. Alpha is an angle, and I use that. But if you think that's confusing, let me just make it easier. Let me call this beta. Yeah, sorry about that. This is bad use of notations. Let me call it beta. So I'm trying to get okay. So how do I find a relation between theta and beta? So I could use sine rule, right? Sine rule will give me law of sine. So this says that 0.3 divided by the side opposite 0.3, which is sine of theta, equals 0.6 divided by this angle here. Okay, but this angle is, I could technically write it as a different angle and then try to sub it, but I'm just going to write that as 180 minus the sum of the other two angles, because the sum of all the angles should add up to 180. So this is 180 minus theta plus, so sine of 180 minus theta minus beta. Okay, so I think that's pretty much what I need. So I'm going to factor this out. So what's 180 minus theta minus beta? I think it's sine of theta plus beta. Okay, it's not quite in the form theta equals f of beta, right? Because sine theta appears both sides. But really, what you can do is you can just differentiate that, no problem. You just differentiate that. So sine of, so I'm taking the derivative with respect to time. Derivative of sine is cosine. And then I need to take the derivative of theta plus beta as a function of time. So that's going to be theta dot plus beta dot equals to derivative of sine is cosine of theta, and then derivative of theta, that's theta dot. Okay, so let's see if we can solve for the unknown, which is theta dot. Okay, this is an unknown. Beta is also an unknown. Theta is also an unknown. Do we know theta? Oh, we do know theta. Theta is known. Theta is known. Beta is an unknown. So we have an expression for in which there are two unknowns. There is beta and there is beta dot. Okay, so we cannot solve for two unknowns using one equation. We got to get the other unknown, one of those two unknowns, using a different equation. We know beta. We know beta dot. Oh, sorry, we know beta dot. Okay, let's see. This is everything which we know. We know theta and we know beta dot. So we know theta and we know beta dot. So we do not know beta and we do not know theta dot. So there are still two unknowns. Beta and theta dot are unknowns. Yeah. So there are two unknowns, which means that we need to get one more equation. This one equation will not help us. Okay, can we do something else to find beta? Since we know two sides of the triangle, 300 and 600, and we know one angle, right? We should, in principle, be able to find the other side, because the rule says that if you know three pieces of information in a triangle, you should be able to find everything else about the triangle. So how do we find beta? Law of sines? Law of cosines. Okay. Law of cosines on which side? Start with which side? What should be on the... So we can use it with this. 0.6 square equals 0.3 square plus, I need to call this side as something, let's call it CB, minus 2 times 0.3 times CB times sine of the angle between opposite to 0.6, which is sine of 180 minus theta, sorry, cosine of 180 minus theta plus p. Cosine of theta plus 180 minus theta plus p. Okay, so that will be with, that has again two unknowns, right? Beta is an unknown and CB is an unknown. So that by itself will not help us. I would use the other side actually, 0.3, just because I usually choose a side such that I know the angle opposite to that side. So in this case, I know the angle theta is 30 degrees. So when you know one angle, try to use the cosine rule on the side which is opposite to the angle which you know. In this case, it's 0.3. So this is right, but it will not give me what I'm after, beta in one equation. So I'm going to rather use this way. 0.3 square equals 0.6 square plus CB square minus 2 times 0.6 CB cosine of 30 degrees.
So you could find the CB.
I could find CB using, yes, I could use law of sines to find, absolutely. There are more than one, there's more than one way to solve this. You can use the law of sines to solve this problem, or you could law of cosines, absolutely. Yeah, I just use the law of cosines. So from this expression, solve for CB. Solve for CB, right? One equation, one unknown, you could solve for CB. CB is I have not solved for CB here. Actually ended up solving for beta. Can anybody solve for CB? It's a quadratic equation. You need to use
Why don't you find CB by doing elimination?
find what? CB?
Yeah, CB.
Yeah, that's what I'm going to find CB from this expression.
Well, you got that at two sides. You can find it.
No, I do not know. Well, you're saying, well, use the law of sines. If you use the law of sines, then actually you do not have to solve the quadratic, but it won't give you the side CB. Well, it will give you, but it will be another step. So let me use the law of sines instead. So 0.6 divided by sine of the angle opposite 0.6, that's going to be 180. Sine of 180 minus theta minus beta equals 0.3 divided by the sine of the opposite angle, sine of 30 degrees. You cannot, because you don't know that beta is 90. It turns out it is 90 actually. It turns out to be 90, but you don't know for a fact unless you solve for beta. So what I did was, in my notes, I did it in a different way. This way is absolutely fine. You end up solving a quadratic equation. The other way to do it, use the law of sines. This is 30 degrees. You can solve for beta. It comes out to be 90 degrees. It just happens to be 90 degrees in this configuration. But the moment b goes sides down, that beta will not be 90 degrees. So do not assume it is 90 unless you solve for it. So if you solve for beta, you get 90. You then shove this in to the other equation. Take this and put it here and solve for theta dot. Okay, the answer is, well, it's just 0. Okay, it's 0 for this particular instant. Doesn't mean it's 0 for every instant. Okay, this turns out to be a very special configuration where it turns out that the angular rate is 0 and the angle beta is 90. So what I wanted to tell you is that there is more than one way of solving these problems. Law of sines, law of cosines. However, the answer is the same because it really is a function of the problem and not a function of the method you solve it, right? Other thing is, once you get an expression, you got to differentiate. That's another key thing you got to do. Okay, is this clear? We'll solve 2 more problems and hopefully it will become much more clear. Okay, the circular cam rotates about a fixed point O. Okay, so the cam is rotating about point O, okay, not about its center, with an angular velocity of omega, counterclockwise is given. Determine the velocity v of the follower rod AB. Okay, this thing is going to move back and forth as a function of theta. Okay, so you're told to find v as a function of theta, and you also have to find it as a function of omega. Otherwise, you will not be able to do it without omega, and actually also without r. Everything which is given to you is there except v. So also given r, capital R and small r. So what's happening is, think about it before you start solving it. When you spin the only thing which is spun is the cam. Okay? So for this point, you pull that fix and you rotate it. In this case, counterclockwise. You rotate it counterclockwise. I'm assuming this is spring loaded, so it's actually going to move back and forth. So when you move it that way, this is going to move. Assuming there's a force here due to a spring, that's going to press onto it. It's going to move back and forth, and that motion is not going to be uniform. It's not going to be constant, right? Because this distance is going to change in a non-uniform way. So v will not be uniform. The only input to this particular mechanism is omega. You're going to find v. So the key thing is, in all these problems, is to find an expression for the distance of point. This point here is, well, representative of the motion of the connecting rod or the follower, right? As long as I can find the motion of this point, it's the same as the motion of other points. It's the velocity of any point on that bar is going to be the same. I'm going to use this as my x, and the reason I do this is because I know that point O is fixed, it's not moving, but the point which is on the center of the smaller circle is going to move. So my goal is find x and then take derivative, evaluate x dot. And x dot, turns out it is actually v, right? The velocity is how x changes with time. So as long as I can find x, I should be able to find x dot. So the goal is to find x using trigonometry. So in order to do that, what I'm going to do is I'm going to join these, the center of the bigger circle, the center of the smaller circle, and try to see if I can find x now. I drop another perpendicular here because now I see that x can be written as a sum of this part and this part. So this part, the first part, is d cosine theta. This is part 1. Let's call this part 2. I need to write an expression for part 2. Okay. So this distance here happens to be, what's that distance? Big R plus small r. That's right, because the radius of the smaller circle is r. Okay, given that, can I now find the length of part 2? You don't know the angle, right? You do not know this angle. Nor do you know that angle. You just know this angle. Okay, let me give a hint. This says 90 degrees, right? Because they're dropped a perpendicular. Do I know this length? It's d sine theta. So if I know this length, I know this length, and I find this length from Pythagoras, then I can, right? That square equals this square plus this square. Or in other words, this part 2 is going to be the hypotenuse square minus the adjacent side, this side. It's simply r plus r square, that's the hypotenuse, minus the side, which is this one. So it's d sine theta square. So that's part 2. Okay, so x dot is v. So I need to take the derivative of the sum. The derivative of d cosine theta is minus d sine theta dot. Plus, so when I'm taking the derivative of something under the square root sign, it's basically 2 square root of the same thing in the square root sign. I'm going to write this as d square sine square theta, okay, times the derivative of the thing inside the square root, which is going to be r plus r square. That's going to be 0. The derivative of the first term, r plus r, is the constant, is 0, minus d square times the derivative of sine square is 2 sine theta cosine theta. Well, derivative of sine square is 2 sine theta, and then I need to take the derivative of sine theta, which is cosine theta, and then I need to take the derivative of theta, it's theta dot. That's my chain rule. Right? This is d dt of sine square theta. Okay, so all I need to do is simplify this. So x dot is v, or v is minus d sine theta times theta dot minus d square sine theta cosine theta dot divided by okay, is that clear? Yeah.
So we have used that equation that you showed us at the beginning, x equals to r sine theta over 2.
You could, but you do not know you have to use that. You need to know this angle. That angle is unknown. Also, remember for that particular formula, this point O is over here, and so it's not in circumference. You would not have been able to use it now. Okay, final problem for today. I may not have time to finish this, but let's try. So bar AB rotates uniformly about a fixed point A with a constant angular speed. Omega is given. Determine the velocity and acceleration of block C. So we need to find the velocity and acceleration of C at the instant when theta is 60 degrees. So again, what I'll do is similar to the previous problem where I need to find the motion of point C. So I choose the point A to be, or the line passing through A to be my origin. So this distance is x, and that x is clearly an unknown. If I can find x dot, and if I can find x double dot, I would have found the velocity of C, which is x dot, and acceleration of C, which is x double dot. This is v and this is a. Okay, so my goal is to find x. If I can find that, I should be done with this problem. Okay, let's try to see what we can find from this figure. I just drew this perpendicular here. Okay. I did that because I want to complete this triangle, and I also wanted to complete the other triangle. That's why I dropped the perpendiculars. Okay, so let's try to write this length here. This length is L. What's that length? Is it L cosine theta? Okay. I can find this length. This length is simply the same as this length here. It's L sine theta. Okay, can I find this length? What's that? L minus L cosine theta. How did you get it? So this is L. You get it from here. Oh, I think you got it from. This is L, right? You're given L and you're given L cosine theta. So this is this has to be L minus L cosine theta. Okay, is that good enough to find X? Let's see. X, I know this is X. This is L plus L sine theta. X plus L sine theta. This seems to be the side of this triangle, one of the sides, right? This side. I know this side too. It is L minus L cosine of theta. So maybe I can use Pythagoras theorem. So I'm going to write this as X plus L sine theta, which is this side square, plus this side, is equal to the hypotenuse, which is L square. So X plus L sine theta is L square minus L cosine theta square. So X is minus L sine theta plus okay, so I have got an expression for X as a function of theta and L, and theta is given and L is given. So I need to find the derivative, and I'll complete this later on, but I need to find X dot from this and then X double dot, and then I should be good. And I could pretty much get the X dot because I know theta dot and L. So I'll complete. I don't have time. I'll complete this later on and post it. So by the way, your second exam next week. Okay, we covered the homework which was due yesterday and the homework which is due upcoming Sunday. The two homeworks. It's just see the sections. If you go to syllabus, everything after exam 1, but before next week, before end of next week is covered. So homework 2 and homework 3 and 4 are part on your.
So anything that we learned last Monday?
Yes, last Monday.
What I mean is all that we learned this week. Like we don't have any new information next week.
No, what you learned this week and what you learned last week.